Dear students, today in this video we'll be learning about geometry. The domains of mathematics that study the shapes and sizes of structures are described under geometry. The word geometry is derived from the Greek word geo, meaning earth, and metron, meaning measurement. So, all those domains of mathematics that study the shapes and sizes of structures are described under geometry. Let us see some applications of geometry. Look at these wonderful constructions. Taj Mahal, Eiffel Tower, the Great Wall of China, our Charminar, the wonderful temples in India, temples abroad. These are all the applications of geometry. Let us know the history of geometry. Ancient Indus Valley and ancient Babylonia, these civilizations know about obtuse angled triangles. There are evidences that these ancient civilizations have the knowledge of geometry. Bakshali manuscript employs problems about volumes of irregular solids. So, this manuscript, Bakshali manuscript, describes problems about how to find the volumes of irregular shapes, irregular solids. The excavations at Harappa and Mohenjo-daro, there are evidences that they know about circle drawing instrument as early as 2500 BC. This is a picture related to Indus Valley civilization. The excavations made here in Gujarat. You can see that they have evidences. There are evidences. Let us know about a great Indian mathematician, Baudhayana. History says that he discovered Pythagorean theorem way back in 800 BC. He wrote Sulabha Sutras. Baudhayana wrote Sulabha Sutras. Ritual fire altars. These are the areas occupy same area although differ in shape. Sulabha Sutra by Baudhayana for squaring a circle and circling a square. So these ritual fire altars were constructed in such a way that even though they differ in shapes, let it be a square, let it be a circle, the area occupied by this circle or square used to be same. So he wrote the formulae how to square a circle, squaring a circle. That means a circle is already there, and then how to get a square out of that circle, that is a square which has same area as that of the circle, given circle. He wrote formulae about that in Sulabha Sutras. Pythagorean triples and also the statement of Pythagorean theorem for the sides of the rectangle. There are evidences, children, that Baudhayana wrote about all this way back in 800 BC. The history says that. These are the Vedic scripts. Look at the picture, children. It is a picture of the mathematician Euclid. He is the father of geometry. Euclid created the first system of thought based on fundamental definitions and rules of inference or logic. So he was the first person who created first system of thought based on fundamental definitions and rules of inference or logic. Based on that, he wrote 13 books, and his books are called as the Elements. Fundamental terms of geometry as defined by Euclid. Solid, it is a three-dimension. It has got length, breadth and height as its dimensions. Then this solid has surfaces, and those surfaces are two-dimensional. That is, when height is removed from three-dimensional solid, we'll get surfaces with two dimensions, length and breadth. Now, when one of the dimension is removed from a two-dimensional surface, that is the breadth, we'll get a one-dimensional line, and point is something which has no dimensions. Euclid listed 23 definitions in book 1 of his Elements. In book 1 of his Elements, he listed out few definitions, 23 definitions. We'll be just knowing about few of them. He says, a point is that which has no part. A line is breadthless length. Just now we have seen. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of surfaces are lines. So, a plane surface is a surface which lies evenly with the straight lines on itself. These are few of the definitions out of 23 definitions given by Euclid in book 1 of his Elements. So, he has defined a point as something which has no part, no dimension, and line is a breadthless length. That means it has got only length, no breadth. Then the ends of line are points. What he means by line here is a line segment. He called it as a terminated line. It has got end points. Then a straight line is a line which lies evenly with the points on itself. So it is a straight line which has got all the points on it evenly on itself. A surface is that which has length and breadth only. Just now we have seen the picture of the surface. It has got two dimensions, length and breadth. The edges of surface are lines. So you have seen the edges of a surface which has got length and breadth as its dimensions. The edges are lines, that is line segments. A plane surface is a surface which lies evenly with the straight lines on itself. Similar as a straight line is a line which lies evenly with the points on itself, a straight line has got points on itself, evenly lies on itself. A plane surface is a surface which lies evenly with the straight lines. So surface has got straight lines. A straight line has got points on itself. That's how he defined. But later on, the mathematicians felt that now to define a point, Euclid said it as a point is that which has no part. Now, we need to define the word part to understand it. Now, if we go on defining part as something from a whole, then again we need to define whole. So, this chain continues, it never stops. So, the mathematicians decided that we'll take few words like point, line, etc. as undefined terms. We'll accept as they are instead of trying to define them. So these are considered as a point, a line as considered as undefined terms. Now let us look at the terminology in Euclid's geometry. Now to learn about this chapter, children, the concepts in this chapter, you need to know few words and the meaning of those words. Let us have a look. You need to know about a statement. What is a statement? We'll be discussing shortly. You need to know the meaning of the word axiom, postulate, conjectures, and theorem. Of course, you heard theorem earlier, but let us try to define axiom, postulate, conjectures, and everything starts with the word statement. So let us have a look in detail about these terms. So, statement is a sentence which is either true or false but not both. So, what do you mean by that? So, it is a sentence, of course, it is a group of words which is either true. That means either you can say it as true or you can say it as false, but it cannot be both. That means true and false at a time. So, such sentences are called as statements. Let us try to understand it with an example. Mahatma Gandhi is the father of India. It is a sentence which is true. 2 is an even prime. Mathematically, when we see that 2 is an even prime. It is true. It is a sentence which is true. So, these two are true sentences. Hence, they are called as statements. Mahatma Gandhi is the father of India is a statement because it is a true sentence. 2 is an even prime is also a statement because it is a true sentence. Now let us have a look at a sentence. PV Sindhu is the Indian women's cricket team captain. Oh my god. PV Sindhu is not a cricket player. So this sentence is false. 0 is the smallest natural number. We know that natural number set starts from 1. So 0 is not a natural number and it is not the smallest natural number. So this sentence is also false. So what we say is the PV Sindhu is the Indian women's cricket team captain and also the sentence 0 is the smallest natural number are false. Hence they are statements. Now let us have a look at these two sentences. She is intelligent. Who is she? Unless I know about her, I cannot decide whether this sentence is true or false. This cannot be decided. Yes, in this similar way, x plus 5 is equal to 8. How can I say whether this is true or false? I don't know that. I have not been given that the value of x is 3 to say this sentence is true. So unless I know the value of x, I cannot say whether x plus 5 is equal to 8 is true or false. Hence, these two sentences, she is intelligent or x plus 5 is equal to 8 are not statements. Remember children, a sentence which is either true or false, which you can decide as either a true sentence or a false sentence, are called as statements. The other things which cannot be decided whether it is a true one or a false one, as an example, she is intelligent or x plus 5 is equal to 8, which are undecided, such sentences are not statements. Very good. I think the meaning of the statement is clear to you. Now let us go to the next term, axioms. Axioms are statements, children. Just now we have discussed statements. Axioms are statements which are self-evident or assumed to be true. That means we are taking only such statements which are true. Okay, we have defined statements as either true or false. But for axioms, we are considering those statements which are true. Statements which are self-evident, that is very clear, or assumed to be true within a context of a particular mathematical system. In any branch of mathematics, if a statement is true, assumed to be true, then we call it as an axiom. Let us see an example. If equals are added to equals, the wholes are equals. What does it mean? Let us see. If equals are added to equals, suppose if you have a 5 rupee note and your sister also have a 5 rupee coin. You have a 5 rupee coin, your sister also has a 5 rupee coin. And your father has given 10 rupees to you and also 10 rupees to your sister. How much do you have? Yes, 5 plus 10, 15 rupees. And how much your sister has? 5 plus 10, 15 rupees. That's what the sentence says. If equals are added to equals, the wholes are equals. So here Euclid used the axiom, that is a true statement which is self-evident. You need not to prove it. You need not go for a proof for it. It is very clear. It is very evident. Just by looking at the statement, you can say that it is very true. Such statements which are self-evident or assumed to be true within context of a particular mathematical system. So in any branch of mathematics, if you see a sentence which is statement which is self-evident or assumed to be true, just by looking at it you can say that it is true. Such statements are considered as axioms by Euclid. Now let us go to the next one, postulates. Statements which are self-evident or assumed to be true, just like axioms, but this word is related to geometry. So the statements which are self-evident and are assumed to be true in geometry, in particularly geometry, such statements are considered as postulates by Euclid. So, axioms are also statements which are self-evident or assumed to be true, but they are considered in every branch of mathematics. Postulates are also statements which are self-evident or assumed to be true, but they are limited to geometry. That is the difference, children. Euclid used axiom throughout the mathematics, not particularly in geometry. That's what I was saying. He used the word axiom throughout mathematics, in everywhere in mathematics. But the term postulate was used for the assumptions just that are made in geometry. If a statement, a self-evident statement was considered in geometry, he has given the word postulate. If it is considered in any part of mathematics, then it is defined as it was considered as axiom. An example for postulate is all right angles are equal to one another. It is related to geometry. It is a postulate. All right angles are equal to one another. It is very clear. If it is a right angle, it has got 90 degrees measure. So all the right angles have 90 degrees measure. So they will be equal. So it is very self-evident. You can see this statement is self-evident. So that is given in geometry and hence it is a postulate. Now let us go to the word conjecture, which is also considered as hypothesis. It is a statement that is an educated guess based on observation which are neither proved nor disproved. So, based on some observation, I will be stating something. Based on my experience and my observation, I will be saying something without proving or disproving it. For example, the square of any natural number never ends with 2. I've just gone through few squares of natural numbers. I've taken a natural number and have squared it. Out of my observation, I noticed that the square of a natural number never ended in 2. So that's why I've given a statement saying that the square of any natural number never ends with 2. So this is just a educated guess based on my observation, and it has neither proved nor disproved. Such a statement is called as conjecture. One more conjecture given by Goldbach. Every even number greater than 4 can be written as sum of two primes. It is a conjecture stated by Goldbach. So it is neither proved nor disproved, but it has made by as an educated guess based on observations. Such statements are called as conjectures. Now let us come to the last term which we were discussing, theorem. A theorem is a statement that is proved by a logical chain of steps. A proof of a theorem is an argument that establishes the truth of the theorem beyond doubt. So this is also a statement, but it has been proved. It has been proved. This statement has been proved by logical chain of steps. That means a logical arguments, the logical reasoning, each step has been written to prove that statement, and hence the word given for such a statement which has been proved by logical chain of steps is called as theorem. And the proof of a theorem is the argument that establishes the truth of the theorem beyond doubt. Now, once the theorem is stated and it is proved, beyond doubt will be accepting. That is a theorem. Example, if two lines intersect each other, then the vertically opposite angles are equal. So it has been proved. So I will take it without beyond doubt. So that's all for today, children. Hope you understood the meaning and differences of the words, the terms used in Euclidean geometry, that is a statement, axiom, postulates, conjecture, and theorem. And Euclid has been considered as the father of geometry. The books written by him are called as the Elements. That's all for today, children.